So first of all, the title is about Introduction to Computation Design, particularly focusing on data, geometry, and its visualization using digital medium. So I guess you guys already, read this kind of short description, but let me summarize this one. So the first one is most importantly, I mean, this is sort of a boring job, but we must get familiar with the dealing with the data things. So I'm gonna start in very, basic syntax from scratch in the Python to up to not like expertise or professional level, but at least we need some experience or some syntaxes to decompose or assemble or disassemble the data that you have to visualize, okay? The second thing is that, so most of the computational designers, they actually rely on some platform, such as Grasshopper, or 3ds Max, or Maya, or SketchUp, things like that. But the good thing for that is that the commercial softwares actually give us boilerplate code, like some class, point, line, and things like that. So, I mean, this is a really good opportunity and good learning process to create your own sort of custom geometry class that you're gonna learn in this class. And then the last one is a little bit burden maybe for you guys, because I'm going to talk about how people develop sort of a visualization or CAD application, which is more about like an engineer side perspective. But I think this is the pretty good understanding in terms of developing you guys your own like visualization tool. I guess once you familiar with the 3 steps, I think it's no matter what, just like a platform, 3JS or Rhino or Python and the Grasshopper or processing, no matter what, you can actually build you guys own sort of package or software, as a visualization tool or the geometric analytical tool, things like that. So this is my aim, of this workshop. So we have actually, I'm little adjusted this one a little bit. So 1.5 hours is the time for every day until 2nd July, I guess. Yeah. From now on, we have like 6 more days. Anyhow, so these are the schedule and some detail. That one's a little bit different than actual code. However, we have here the link. So one day here, if you click it, you can jump to this Medium page. This is today's agenda. Yeah. So today we are going to focus on the data processing and particularly, let's say, Grasshopper environment or Core environment, which is the online Python platform developed by Google. So as long as you can access the internet, we can actually create our own Python code, which is really good. And particularly, we want to understand really basic syntax to like a list and a for loop and things like that. And also, there's some additional material, some Grasshopper component. If you click it, there's several Grasshopper component and the let's say plugin. Yeah. So I have some sort of additional like exercise things using the plugin that I developed. So which is about visualization or mapping, some image processing things. We're gonna reach that one maybe tomorrow, not right now. But I'm recommending you guys to download and install in Grasshopper environment, right? So if there anyone who never used Grasshopper, can you say something? Can you raise your hand? Everyone knows Grasshopper, right? Great. Yeah, and then the other additional material is the ThinkPython PDF. Actually, you know what? This material is very famous and really, really well organized for the people who wanted to, dive into computer science. So I highly recommend use this book after this workshop if you are interested in keep developing the ability to, computational design or algorithm things. So I'm just leave this link here. And the other additional note is, the Python 101 things, from the Rhino Magnet company. So I think also this is a good material. But the difference between the material and ThinkPython is that ThinkPython is more about like a genetic syntax and algorithm stuff, right? And then the Python from the manual is more about like how to cook the the Rhino's API, just a point, line, and things like that. But again, as long as you are familiar with the syntax, you can actually deploy same exact syntax to different platforms such as Maya, 3ds Max, and Cinema 4D. They actually support the Python. So these are sort of an overview of what we are going to do today. And then also, yeah, I don't know, the conference team asked me multiple
Hay que esperar porque está...
Yeah, so there's some the material. Actually, as I said, I'm a computational designer, but particularly I'm a person who very into design. So, sorry, I'm very into the data in design practice. So I'm actually over the overview all of my project and how can I do and what is the philosophy behind the scenes. So if you guys are interested in my thought and my understanding of computation design, I highly recommend you to just visit the English version, and then Korean version is for Korean, by the way. So this is the sort of my thought about data and design. So particularly, even if we use the data to just visualize. So actually, data out there is it has a lot of noise and a lot of a lot of bad things we need to still instill, or we need to clean it up. So in order to use the data, actually we need to think about like some of the methodology, how we instill or how you refine the data, and then maybe you need to apply multiple sort of strategy to clean the data, and then we call it some of the system. So basically, what the visualization is just not just convert to the numeric number or computer language to the visual language that human can see. It's not about it. The visualization is more about like revealing some insight. We need to not watch the visualization. We need to read the visualization. This is what I'm trying to talk. So actually the data in design practice, I know you guys, most of you guys is from the urban design or geographical related things, but remember, there's a lot of data at different scale, like from the geometry or architectural level or landscape and computation, even in action level. So I'm interested in this kind of the data, and then all practice in different scale, they need a visualization. So not just for urban design, even the fabrication, they also need to visualize their like geometry information such as the vector, yeah, or like a connectivity or coverage, things like that. So as I said, the data as technology getting evolved, and then we actually produce data in everyday life, and then even the designer access the data such as big data to take advantage of data is basically representation of our lives, yeah, to make their own design process or decision-making process, things like that. And then software, basically we are developing visualization software, yeah. So my understanding of the software is not just commercial program, just like Photoshop or Excel, I'm not talking about this kind of, I'm sorry. My understanding of the software is more about the package of the knowledge and technology. Yeah. So how we organize the knowledge. So for example, vector, for example, without the vector, we couldn't describe anything in spatial information. Yeah. So for example, yeah, the vector is a very well-defined mathematic things, throughout the history. So we just take advantage of this kind of the well-defined, the math equation or science or history, things like that. So we basically assemble this kind of knowledge, and then on top of it, we actually create some API or interface to access or to trigger one function, which function has the other trigger the other function, and functions like chain effects based on your design or your decision-making process. So this is all about the visualization. This is my understanding. So as I said, the CAD system, the only difference, the CAD system is a very, I have one slide that I can show you 4 days later, but the CAD system is very close to interaction things. Yes, because there's only one program, there's a lot of UI and a lot of things, just like game, you know, once you click something, it not just create a point, it has, once you populate the point in a scene, the point become relationship with the entire environment, yeah? So we need to understand this kind of things, and then we are able to visualize in this kind of, you know, the language or data, you know, as a visual form, right? So the CAD technology is like an open the interaction, and you know, basically the CAD is a multiple different single functions execution, and then we can package them as some meaningful action for design or whatever. And then the web environment is a, you know, actually this is a little bit long history, but you know, Microsoft, Google, and Apple, they actually fight each other behind the scene. Which one is in order to get the paradigm, you know, the shift. But one thing I can for sure to say is web become more and more popular. Even we don't need to install something on Windows. We use the mobile phone or even the micro world or PowerPoint. Everything's migrated from the local environment to the web environment because this is the paradigm shift. And then a lot of people, you know, get used to using the web environment. So the reason I picked the web environment is because we need to prepare our future, right? So the web environment is so the things where we need to understand. So as I said, the visualization is not something drawn on the screen. We need to interpret. We need to revealing some fact, right? So in this case, I think I got several questions about this kind of things. So what is the best visualizations? My understanding of the best visualization is not visualizing something fancy to attract people's attention. It's more about like how we apply our domain knowledge as a visual representation on top of the data, which is fact, right? So I think the domain knowledge is really important. Otherwise, we couldn't read the visualization things. So we are jump to other section. So recently I found this article, which is very useful for you guys. There's a sort of a, because I sometimes people ask me, Andrew, what is the data, right? So my answer to this kind of question is, as long as you can qualify or quantify, or as long as you can recognize, we can consider this is data, right? So this is a very high level interpretation of what is the data. But in the computer science or statistical people, they actually, you know, they have our own sort of map that we can, take advantage of it. So there's a data type, like a categorical data type and numerical data type. So my experience about the urban data visualization is most of the data is like a numerical data because it talks about some number or population, some statistical things. And also we need like a geographical position, like latitude, longitude, or elevation, things like that.
刚刚来这个城市的时候上课的时候，第一节课就是做到50的时候，第一句 My name is Leo and I'm
yeah. So this is a sort of the data type, and also we have a categorical data type and nominal and ordinal. It's like a red, yeah, blue. So we cannot make the length. So there's also this kind of the data things. So I highly recommend you guys read this article and then get the sense. I mean, this is not important right now, but you guys getting, as time goes by, is getting familiar with, and then sometimes we need to convert nominal data to the numeric data or interval data, things like that, in the pre-processing of the data to visualize. So this is kind of something, the knowledge that we need to understand behind the scene. Yeah. So the link is there. So now we are reach one of the boring things for the coding stuff. So I'm going to click the link, the Python page, the Google Code app. Okay. So you guys can also click the link